Okay, here we go. Lesson 7, solving polynomials by factoring. The key point here is this is not new. We have been doing this for quite a while. We did this with quadratics, just like in Unit 2. We used quadratics. We'd factor them using any of the methods we know, guess and check, slide and divide, AC method. Remember, if you're not comfortable with guess and check, go back and watch one of those videos, the video in Unit 2 on how to factor alternatively. But with quadratics, we factored them, and then the next step was setting them equal to 0 and solving. And that's what we're going to do right now. The only thing is we're doing it with higher degree polynomials. But the steps are all the same. So let's take this one right here, number 1, and go back in time. And say we had x squared minus 6x minus 7 equals 0. Well, we'd use any method we want, guess and check. Easy to do with a prime number here, 2 prime numbers in fact. Here we're looking for 2 numbers that multiply to give us 7 that differ by 6. Well, there's only one choice there because it's prime. And since this is negative, we want the 7 negative and this positive. Now at this point, we would set both of them equal to 0, solve, and we would say that x is equal to 7 and negative 1. That's the solution to the quadratic x squared minus 6x minus 7. That's all well and good, and it's pretty much the same procedure, except we're going to get different answers when we start with x to the 4th. Remember in lesson 6, we talked about when we have an even exponent, just divide by 2. We did that back here. What's half of 2? 1. We may not have thought about doing it, but that's what we were doing. X times x is x squared. X squared times x squared is x to the 4th. X to the 3rd times x to the 3rd is x to the 6th. So when they're even, we're going to end up dividing by 2, and that's our exponent. Now, we still need the same numbers, 7 and 1, and it's still going to be negative 7 and positive 1. The only difference is now that when we do this, we are going to get x squared minus 7 equals 0, x squared plus 1 equals 0. I'm going to add 7 to both sides, and we're going to get positive 7. X squared equals negative 1. Take the square root of both sides, and that gives me x equals plus or minus the square root of 7, and x equals plus or minus the square root of 1, which is 1, but we need to take care of that negative, which is I. We could say 1i, but we're basically done. Moving on to number 2, let's see what we can take out. We can take out 7 for sure. We have x cubed and x to the 1st. We want to take out the smallest exponent, x to the 1. Now we divide. 7, nope. 7 divided by 7 is 1. X cubed divided by x to the 1st is x squared. Minus 1. Why is that? Because we are equal, 7x divided by 7x is 1. Now we set each of them equal to 0. 7x equals 0 divided by 7, and we get 0. Over here, x squared minus 1 equals 0. Add 1 to both sides, we get x squared equals 1. Square root, x equals plus or minus 1. Now when you move on to number 3, hopefully you recognize that these are all perfect squares. Therefore, since it's subtraction, it's a difference of 2 squares. So now we just take the square root of 25, the square root of x to the 4th, divide by 2, the exponent, the square root of 36, 1 plus, 1 minus. Now we solve. 5x squared minus plus 6 equals 0, and 5x squared minus 6 equals 0. To save space, I'm going to subtract 6 and divide by 5. And I'm going to add 6 and divide by 5. Now I take the square root of both sides, which leaves me with x equals, I need plus or minus always, I need the I to take care of the negative, 6 over 5. X equals plus or minus square root of 6 over 5. On to number 4. Now you may notice I need to move the 12 over, and when I do that, I get negative 3y squared plus 8y plus 2y squared cubed, minus 12. And if you tried right here, don't write this on your paper, because I'm going to erase this. But if I tried to factor this right now by grouping, only thing I could take out of here is a y, which would leave me negative 3y plus 8. Well, there's no way I'm going to get anything out of here to give me negative 3y plus 8 here. It just doesn't work. There's no way with this formation for it to work. So here's the key point. Put them in descending order. 2y cubed minus 3y squared plus 8y minus 12 equals 0. Now, when I group them, it works out. I'm going to take a 2y squared out of here. Sorry, I'm not going to take a 2y squared. I'm going to take just a y squared because 2 does not go into 3 evenly. That's going to leave me 2y minus 3, which is what I want over here also. Can I get that? Yes, by dividing by a positive 4. 8 divided by 4 is 2. Negative 12 divided by 4 is negative 3. Since these are both the same, I get these two hooked up. Y squared plus 4 equals 0. And 2y minus 3 equals 0. I'm going to need the room, so never mind. Not going to work. I'll make it work. So I need to do y squared equals negative 4, square root of both sides. Y equals, square root of 4 is 2, plus or minus always. But to take care of that negative, I need an I. So plus or minus 2i. Over here, I'm going to add 3 to both sides. Divide by 2. Number 5. Got a lot of stuff to move. I need to add 5x squared and subtract 30 from both sides. Show your work to make sure you don't make any mistakes. If I write it in descending order, I get x cubed plus 5x squared minus 7x minus 35 equals 0. Now I'm going to group them. I can take an x squared out of here and get x plus 5. That's what I want over here. So what do I need to divide by to get positive 1x? I need to take out a negative 7. Hook them up. X squared minus 7 equals 0. X plus 5 equals 0. X squared equals positive 7. Square root of both sides. X equals plus or minus the square root of 7. And over here, x equals negative 5. Number 6, always look for the GCF. I cannot take out 2 because of this negative 11 is not even. But I can take out the smallest exponent, x squared, which gives me 2x squared minus 11x, x plus 12 equals 0. So I have x squared. I'm going to factor this. Now, 2 is prime, so I'm going to start there. 2x and 1x. For my 12, 1 and 12, 2 and 6, 3 and 4. I need two numbers I'm going to multiply out that add up to negative 11. Since this is positive, they're both going to be the same sign. And they're both going to be minus, because they have to add up to that. Okay, so if I do 2 times 4, that will give me 8. 1 times 3 will give me 3. 8 plus 3 is 11. So now I have x squared equals 0, so x is 0. I have 2x minus 3 equals 0. I'm going to add 3 and divide by 2. And I have x minus 4 equals 0. Add 4. And there are my answers. Okay, now a couple things that are different on your paper than what you see up here. For one thing, this box is not on yours. So I would suggest pause the video and copy it and write it right here. It should fit. Okay? That's my first suggestion. Secondly, you'll notice these red numbers here, -5, -2, and 24. Those do not match what's on your paper. You have -7, 5, and 21. That is a mistake. Please scratch those out, whatever, white out, but write these numbers in, because you can see these are the numbers, the coefficients of our polynomial. So those are 2 things you can fix right now. Hit pause and fix those. And now that you're back from pausing, hopefully, talk about this factor theorem. It says the binomial x minus r, which is our x minus 3, is a factor of the polynomial p of x, p for polynomial, if and only if p of r it was so close. Also right there, p of r equals 0. In other words, this is a fancy way of saying when we evaluate this number, it is a factor if we have a remainder of 0. Which, if you just go back to like we've been talking about with grade school, 7 into 28. 7 goes in 4 times with no remainder. 7 is a factor of 28. But 7 into 29 goes in 4 times with a remainder of 1. Which means 7 is not a factor of 29. Yes, 7 goes into it, but not evenly. And that's all we're talking about here. Does this x minus 3 go into this polynomial right here evenly, without remainders? So let's see. We write our 3, we write our 1, -5, -2, 24. Remember, make sure you have 3, 2, 1, none. We have that. We have our cubic, our square, our x to the first, and our constant. Now we drop the 1 down, multiply by 3. That gives us 3 on this spot right here. We add and get -2. We multiply by 3 and get -6. We add and get -8. We multiply by 3 and get 24. Add and we get 0. Now, all we're doing now is doing another step. Past couple days we've been doing this. 1x squared minus 2x minus 8. And we said that was our answer. Well, now we're going to take that, set it equal to 0, and factor. So here it is factored. X times x is x squared. We get negative 4x and positive 2x in the middle that join together to be negative 2x. And negative 4 times 2 is negative 8. Then we set each of these equal to 0 and solve and get our answer. But now the thing is, we got to remember, it's not just these two. We have to remember our original divisor right there. So those are our zeros. I will be talking more about that as we move on in this unit. Remember, zeros are the same as roots, solutions, x-intercepts. Okay? We were used to them from quadratics being the points that hit. But now we're talking about graphing cubics and other functions. So it's going to get a little bit more complicated. So here we go with example 8. Start to finish. Now, the key thing is, make sure you have everything in order. This one is not in order, so we need to rewrite it as x cubed plus 4x squared plus 9x plus 36. We have 3, 2, 1, none. So now I can do my synthetic division. I set this equal to 0, which will give me negative 4 in the box. 1, 4, 9, 36. Drop the 1 down, multiply. Add and get 0. Multiply. Add and get 9. Multiply. I get 0. Now, what that leaves me with is 1x squared. I don't have an x to the first. That's what the 0 is for. And I have plus 9. I set that equal to 0. And now I factor it. This is a sum of two squares. So I'm going to get x plus 3i and x minus 3i equal to 0. I still have to solve them both. Kind of running out of room. So my answer is x equals plus or minus 3i. Because I have both of them. If I subtract 3i here, add 3i here, there's where I have plus or minus 3i. So my lead coefficient, I get that right here. Or right here. It's 1. The degree is 3, which makes it cubic. And factored form, okay, this is the tricky part. You've got to remember our original divisor. So it's actually x plus 4 times x plus 3i times x minus 3i, which leads to our zeros of negative 4, negative 3i, and positive 3i, which once again could be written as plus or minus 3i. Just want to show both ways. And the last example. Is it in descending order? Yes. Set this equal to 0. I get x equals positive 2/3. 2/3 is the number that goes in my box. 3, negative 5, negative 16, 12. 3, 2, 1, none. I'm in good shape. Drop down my 3. Multiply by 2/3. If you need to do this on the other side of the paper, that's fine. Two ways to do this. 2 times 3 is 6. Divided by 3 is 2. Another way to do it is, that's a horrible 3, is to say the 3's cancel and I end up with 2. Either way, I get 2. Negative 5 plus 2 is negative 3. That works out nicely because the 3's cancel, leaving me negative 1 times 2, which is negative 2. Add those together to get negative 18. 3 goes into that. Negative 6 times 2 is negative 12. It zeroes out. It is a factor. Now, we started with cubic. Let's just do that right now. We start with a 3, degree of 3, cubic, 3's all around. So since we started with the cubic, our first term is going to be squared. Minus 3x minus 18 equals 0. Greatest common factor, I can take a 3 out. X squared minus x minus 6 equals 0. When I factor that, I'm going to get x and x. I need two numbers to multiply to give me 6 that differ. Okay, I want to make it look like an equal sign. So that differ by 1. Well, that's going to be 3 and 2. Since I want negative 1, I want that to be negative and that to be positive. So now the factored form is 3 times x minus 3 times x minus 2 times, don't forget our original one, 3x minus 2. And the roots are, well, we already know, 2/3, which comes right from here. And then x minus 3 set equal to 0 is positive 3. X plus 2 set equal to 0 is negative 2. And there are our roots. Notice here we said zeros, here we said roots, x-intercepts, solutions. These are all interchangeable terms.